Sandy even on?
I'm here.
Yep, she's there. Okay. Actually, here we go. Got it from the straight. Okay, status.
It looks like Tony's audio is coming and going.
There we go. Wow, that's weird. So I'm going to try to present this way and see how this flies. Presentation view doesn't help me. Is there a share? Because presentation's inline. Show of hands. Start.
There's a share screen at the top.
Share screen. Share preloaded slides. It says, yeah, no slides available because nothing's there. Weird. Didn't link. That's too bad because last time it worked really well. It was great. That would just go to the data tracker of all the uploaded slides, and the presenters could grab them themselves from that link and go. So we went backwards this time around. Sorry, I'm not certain what's broken with it. Probably because they bounce us around location-wise, I'm guessing. But I'm still figuring out how to share something here.
Is there a Meet participant here in the working group who want to step forward and be helpful?
Doesn't sound like it.
Yeah, no, that they're not shy, but maybe it's really a bug because the meeting got moved.
That's what I was thinking. That seems the most logical conclusion. But quit that. All right, so I'm down to just this. I don't want to quit all this crap too. That's there. There's my deck. Garbage nobody wants to know about. Okay. Nope. Not quite. That's the deck. It's there. I think I'm done. So let's see if I can share this thing old-fashioned way. Before it goes fractal on us. There we go. Can you see that?
Yes.
Okay, what if I probably go full screen or just do this? That's the safest way to do it. All right, now the trouble is, Tony, I can't, when I go full screen to show these slides, I can't see the Meet Echo interface at all. I'm totally blocked out. So I'm going to need someone, you and Sandy, to manage all the questions.
I will manage the questions.
And okay, this is just with my slide deck. I've got the other ones queued up if I have to run them this way, but hopefully the others can grab theirs and share their screen and it won't be so crazy. Also, the video link. I'm looking to grab that thing again, and I can't seem to have, because we have one presentation that's going to be preloaded, correct? Come on. There we go. That's always a great effect. All right, I just got it. Awesome. That died. I'll quit that. And where'd that link go? Here it is. It's bizarre. Okay, I'm not certain what that link is doing. Let me grab it somewhere else. It's probably loading, I'm guessing. All right, that one's down the queue. Yeah, still loading. All right, cool. Back to this freak show. And bam. No, wrong one. That one. All right. Welcome to beer. Thanks for your patience on this one. This is unfortunately a little snafu we hadn't seen before. This worked really well last time with integrated with our docs. Not now. You don't need to sign blue sheets. It happens automatically now, which is pretty darn cool. Note well, please note, I don't think this has changed in a little bit, but still understand what the rules here at the IETF for proper behavior. I need someone to take minutes, please. Focus on questions at the mic, stuff that's not being, in the presentation itself. And of course, all this will be recorded so we can score you on how well you kept minutes. Any hands? Anyone? Tony, can you manage the hands? I'm putting a big order on someone who's midnight or 1 a.m. right now, but
Will do.
this is broken, so I need an assist with hands. Tony? Anyone else hear me?
Yeah, no one there to manage the notes. Any volunteers?
All right, I hear you. You got to get your volume up a bit, though. It's really bad. I don't know if it's me or considering how much I've got going on here. There we go. That video works. It's loading up. Cool. All right. Work on that. Docs update. So we have a list of drafts here that are in ISG right now. Some of these got moved quite a while ago, but feedback immediately was the ISG queue is ginormous. So that's all right. We've done our bit and we're moving on, waiting for some feedback. So moving to those who are in last call. We've got LS, MLD, waiting for a shepherd. So this is going back again. We've got 4 drafts here that actively do or will be needing shepherds. Please jump to the list. I'll call each of these out again at the list after the meeting so we can start making progress. And as you've heard me say before, it's a great way to jump in. If you haven't authored, if you haven't contributed, you're looking for a way to get your hands in how the process works, this is a perfect way to jump in through it. It's actually fairly simple. There's just a list of Q&A that you go through to ensure that each of the check boxes have been done for each of the drafts before it moves on to the ISG queue. I will take these a list and please respond. Here's some that are actually pretty clear, working towards working group last call or even there. Again, here's 3 more shepherds. So we're at 7 now. And we got some old stuff. We got stuff that's expired, quite a few actually. And I don't know if these are coming back or not. If you're authors of these and you feel that you want to keep pushing this forward, let's jump back at, refresh, and bring them back to the list. Otherwise, they will die and rot into the history of the IETF. All right. So again, these are expired, but we've got people working on updates. Some are complete. One here is completely dead. Just continued from the list before, actually. So same game. If these are things we want to, as authors, you want to see move forward, there's been good response to the list yet, and it's just been a timing thing. Feel free to refresh, bring them back to the list, and we can start moving on these. Now, the big work in process, 8279, we've got a good list of volunteers. Nothing's been produced from them yet. I imagine there'll be an interim being scheduled. I believe Sandy's taken the lead in this, which is fantastic. So Sandy, feel free, pull an interim together on this, either with the focus design team if you need to, and go at it. We're anxious to see some progress in this group. Got 2 new drafts. I think, are these being presented? I'm not certain, sorry. And then the FRR, so it's been merged. There was a request from the chairs and at the list to actually have a section that talked about how beer operates in conjunction with the IGP. That didn't happen in the merge, and there was some hand waving as why it didn't happen. But honestly, we need to listen to the group. We need to listen to feedback. You don't march forward on these things alone. This is why we fall into pits in the past. We've had working documents in the past where they refused to listen to the group since Rev 0 and no progress was made. So these things are important. We see this not just from the chair, but this came from other participants, that in order to gain context of what you're trying to do with FRR, having a section, a dedicated section that talks specifically about how it operates in conjunction with the IGP. So then we have context to understand how this is modifications to implementations to allow for operating with different control plane, then here we go. This is a great way to do this in an architecture for the document. Doesn't change your content any. It just helps the document fit the frame of the way people think when they're reading this stuff. So please consider that, bring it forward. The author list is also gigantic as well too, and that needs to be pared down as was confirmed by the AD. That's kind of the history of the IETF. We don't push documents forward with gigantic lists. Okay, and here's our agenda. A lot of stuff. Before we got there, anything jumping out, anything missing, anything we need to change, anyone not here needs to cover? Any hands, Tony? I can't see hands.
Hand.
It's a hand. Now what do we do? There's a hand. Hand?
Yep. No, so with respect to, you know, taking feedback into account, so what I've seen, what actually works in the people using it is that, you know, the GitHub are great as issue trackers, right? You can bring up your issue in there, whether your chair or somebody else, and then you can go back and remember these things. That's the best thing about GitHub. All the other stuff is crap, but you know, we don't have sorry, we don't have a comparable tool. So if something like that FRR or whichever draft you're thinking of, you know, needs more communication, I think it's better structured than these, you know, mailing lists where it's really hard to find stuff after a while. Thanks.
Yeah, absolutely. Actually, you outlined that really well on the request for volunteers for the Rev of the architecture RFC. That was fantastic. I appreciate it. We have another hand.
Hey, Greg. Alberto Rotunda, Routing AD. So to what Torlis said, I don't have any problem with the working group using GitHub for specific drafts or in general. However, I need you guys to agree on how it's going to be used. Meaning, is everyone going to go to GitHub? Is it only going to be used to track issues? How are the discussions going to be made? You know, normally we configure or we confirm stuff on the list. Some working groups, if you look at Quick, for example, everything was pretty much done on GitHub, and that's fine. We just need to make sure that there is you know, clarity, and that anyone that is following the mailing list knows what to do, right? And is not lost and it just doesn't see any discussion. There are a couple of RFCs that were produced by a working group that was formed to do GitHub stuff. I'll forward them to you guys so you can take a look. And there is an IETF organization GitHub, so we can put the repositories for beer in there if that's what we want to do. Just so you know, I think if you go this way, you would be probably the first working group in routing to officially use GitHub. I mean, people use it all the time for their individual drafts, not to track working group comments and things like that up until now. So, you know, others will be looking at you guys on, you know, to learn and to get best practices later. So I'll send that to you guys.
So you said Quick's doing everything up there. Is there any group that's doing like just individual draft done through the whole process, not just the authoring, but the feedback and tracking all the way through publish?
Yes,
I'm just saying working piecemeal instead of total.
Yes, there are many working groups that are doing that, and I think HTTP Biz is doing some of that, where some of the draft work is done on GitHub and others somewhere else. The point is that we need the working group to agree on how we're going to work. Is it everything?
Yeah,
is it only a piece? Is it, you know, whatever it is? I'm obviously fine with it. It's just a matter that everyone needs to know, and everyone needs to understand where in GitHub everything is and how to interact and how to do the discussions and everything else. So again, some of this is detailed in the ROCs that I'm going to forward you guys.
Great. So just as a possibility going forward if we wanted to try this. I mean, it seems like a whole lot to bite off to say, oh, everything's moving there, and people haven't figured out what that means yet. And even if we did that, say the chairs were prepped and we did it, getting the group moved over from paying attention to the list to paying attention to GitHub is not a simple task. Seems to me it would be tackle something that we do on GitHub, and we get the feedback from the list on how it worked, and if we liked it, and if it was easier, and on and on. And then we can decide, you know, we start moving things over that way. So Torlis,
That sounds like a really good idea. Yes.
Yeah. I mean, what I was saying is
Torlis,
also,
I think you're on.
yeah.
Right, Torlis.
So I wasn't referring to the official process of the IETF with GitHub. I, as a working group chair, I've also haven't gotten around to figure out how much overhead it is. But you know, many contributors have been doing GitHub for their documents forever, so it's very easy to duplicate, you know, comments and issues, you know, on the mailing list and put them into the GitHub, and then these authors are a lot more responsive to the issues. That's a very lightweight approach, and that's what I would recommend. As far as what Alvaro is saying about all the official stuff in the IETF, I don't have opinions yet on that, but need to get them.
All right, Tony. Tony? Tony? He had his hand up. Huh. I give up on him. Oh, he's back. Tony? Can we hear you? No, not certain. I don't know if his audio is messed or what. He was kind of muddly before. So first item on the agenda. Thanks, actually, both of you for that feedback. That's a great way to track stuff. I agree, Torlis. Searching stuff through the list has just been arduous, and after 2 decades of this, it's insane. Trying to go back, and I said what, when? So first on the list is Torlis with the with the TE ARC. Do you want to watch the video, or do you have a presentation first, Torlis?
Brte has
like
nothing
presentation
to do with our stuff, so let's just can I, what is saying, sharing? Have
yeah, if you
screen
can share, that would be great.
So how is this shared? Sorry, I'm just
upper left-hand corner. You see your name under beer, and then the list of icons there. The one that looks like a screen says share screen. Should have a slash through it. Once you click it, the slash goes away, and we see Torlis's face.
yeah, but how about my screen? Is that shared?
Can you do share screen? Upper left corner.
Yeah, I clicked
see those
on that.
four...
It says.
Oh, it's giving me grant screen. There it goes.
Yes,
it had
do you really want to share your screen?
It sent me a request.
Right, window, and I want to do, is that the beer one? And share, and there we go, and Control Alt F, full screen. So is there sharing? It sounds like there is an audio feedback that it's sharing. Okay. So what is this slide saying? Oh yeah, so this was reported only at the non-IETF107 interim, since then not. And this slide says time flies when you're having fun with Corona, but everybody was very busy. So I have 4 slides of what hopefully are the technically interesting aspects of the textual improvements between 09 and 10, which is Alvaro's responsible AD review. You could also call it an Iowa class broadside against the textual inequality of the document, which hopefully is now fixed. And so, yeah, so there were a really good recommendation for the restructuring. So there are a lot fewer high-level sections there. There is everything that is related to the controller is really informational, because obviously we were not specifying the controller protocols and Yang and all that stuff here. So that's one big section, and then the rest of the stuff was resorted to fit this. And there are also what is saying, things like better comparison with beer, like for example BIRT, which is related in beer for how the routing information gets into the forwarding table. That's also optionally in Brte, because if we don't have local routing, local control plane aspects, we don't need that. So those things are there. A lot of terminology matching with 8279. So the beer layer is now described as constituting of the beer forwarding plane and the BRTE forwarding plane and BRTE control plane. The BRTE controller is not the only part of the BRTE control plane, but just called the reference model for the control plane, because any other implementation option would be a lot more explanation, so it makes it really easy. Also, fancy thing, the do not reset bit was changed to do not clear, because I somehow have been always using how to set a bit to 0 as reset, and 8279 was calling it clear, so I'm of course now also using clear. I think that's a lot more clear terminology. So yeah, so there was one section that Alvaro wanted to have for topology discovery and creation, right? So there are a couple of different things the IETF has to discover topologies in a controller, BGPLS. There is a Yang model from Alex, and there are other options listed. And then, of course, the creation as a function of the controller, taking the physical topology and figuring out which adjacencies to create bits for. So that's better described now. The question from Alvaro, which was very weakly answered in 09, was how to distinguish in forwarding beer and Brte, and it really is a matter of distinguishing, what BIFT to use for a particular packet, and that really is something which also in the beer architecture wasn't really very clearly, described, because 8296, of course, came after 8279, and so there is the BIFT ID field, and you simply need to indicate, if you're just using the whatever BIFT ID in a beer packet, you just need to have some configuration that says whether that's beer or BRTE logic, so that you know what the semantic of the bits is. And then the question is whether that BIFT ID needs to be derived from a combination of BSL, SD, and SI, which is what 8279 originally says. But obviously in MPLS forwarding, this is derived from the control plane. So if you don't use, for example, the IGP signaling that you use for beer, if you don't use that for the beer TE BIFT IDs, then obviously you can simply assign any free BIFT IDs for BRTE. And if you look into the non-MPLS encapsulations, for which there is a draft from ICE and others, it has multiple options. Ultimately, this is something which I wish would be easier to explain. But in the end, there is a lot of flexibility there, and maybe the simple operational recommendation is to say, try to map everything from BIFT back to BSL, SD, and SI, and then have disjoint SD spaces for beer and BRT. Some SDs are beer, some SDs are BRTE. There may be reasons against it, so there is a lot more text about these different deployment options when you have both beer and BRTE in a deployment. So any feedback on that, obviously, more than welcome. Number 3. So the explanation of the two pseudocodes and why they're two pseudocodes are hopefully a lot better explained, and it's all about the reuse of the FBM from the beer forwarding plane. So the first pseudocode is with the use of the FBM, and the second code pseudocode eliminates that, and this also goes back into what is required BRTE forwarding and what's not. And so what I made as required is what can be implemented with the FBM semantic, and the things that are recommended should or may cannot be done with the FBM. So you need to basically have forwarding code that is optimized for BRTE, and that hopefully is now a lot clearer. So the FBM is kind of this intelligent thing to track the bits and reset them, and the logic of that can be changed for the mandatory BRTE. Simply one line of code different, but once you get into some of the things like the DNC flag, the do not reset flag, or sorry, do not clear flag, as it is correctly now, you basically don't need the FBM. It's actually saving, right? The FBM is another bit string length entry for every bit. So the BIFT becomes more compact in Brte than in Beer if you don't need the FBM, and it's really just for Brte it's overhead, and so can be implemented more efficiently. So, and I think we're on the last one. So yeah, so more ASCII pictures in several sections where Alvaro was asking for it. And then the fun part, security considerations. So I was following everything pretty much that Alvaro was asking for. When it came to the security section, he said, well, there needs to be more text so as to not attract too much attention from security folks. And well, what's the biggest difference? It's the controller. So there must be all type of problems with the controller. And so me as an author acting as a public defender for Brte, and having had some background in the security stuff from other recent work that I've been doing, I did exactly the opposite, which is trying to explain how using a controller is so much more secure than using an IGP, because there is a lot of history in the IETF not having done good job on securing an IGP, and that has nothing to do with Beer, just that the standard model of 8279, of course, is to rely on the IGP, and we've done all these things. And how good is an IGP secured? And if you get access to the network and inject wrong IGP information, you bring down the whole network. Whereas if you have a controller, you attack one node, you can't attack the control plane of the other nodes, right? And controller interaction uses TLS, often very good secured. So highlighting how much better it is because of the controller. The misconfiguration, I'm not even sure if misconfigurations are a valid topic for the security section, but I was elaborating on what the biggest misconfiguration issue is, and that's around looping packets, which is why Beer and Brte have strong clear bit rules in the forwarding. And in Beer, the weakness, of course, is the IGP micro loops. Again, it's the bloody IGP with that needs then to go to TTL expiry. And we only have an equivalent case in Brte with the DNC flag. As long as we don't have DNC, actually, Brte has less looping issues than Beer, because it doesn't have that micro loop issue, because every bit is already cleared by the forwarding rules when it passes through a node. Yeah, then also the fact that a lot of the candidate deployments I can see for Brte is not necessarily the service provider space where we started Beer from, but also with the interactions with Roll and others, industrial embedded environments. And so not having a dynamic control plane at all, but provisioning everything up front, having static BIFT tables for live forwarding or so, gives a couple of really interesting deployment models which take a lot of security from the control plane out of the picture. So that was basically the security section. Maybe an interesting read for you folks. And that's it. Questions?
AC, go ahead.
Of the Brte controller?
I only heard of the Brte controller. I think you got lost the beginning. Can you please repeat?
Implementations of a Brte controller. Implementations?
No, I'm not aware of any. And Brte controller, of course, is a word to saying, that could be a person that is, configuring CLI, right? It doesn't have to be, explicit automated software.
There is, however, an implemented automated controller for Beer that was put together some time ago, and I believe it is on GitHub. Making those extensions for TE probably would not be a big stretch.
Alvaro.
Okay, thanks.
Alvaro, running AD. So I just want to say that the slides make it look like there were a lot of changes, and I think the changes were significant, but most of them were clarifications. And as Torla said, you're explaining a little bit better some of the things. I did start the IETF last call because of that, but there's a difference of about 10 pages between 9 and 10. So it would be great if some of you guys took a look to make sure that we're not missing anything obvious. There's at least another week and a half or so of the IETF last call left. So please go take a look.
Yeah, I also sent an email to that extent. Please provide feedback to the TEAS working group, which had a completely full agenda, so I couldn't present to them. But I did go to them several IETFs back when we started this effort, because they would probably be the control plane experts on things that they're interested in. So maybe we'll also get reviews from them.
On a side note, Torles, I would appreciate if you have a good look at the Yang model, because I reviewed the Yang model a couple of times, and I was especially pointing out that it should have enough flexibility, right elements to support something like Brte and the controller programming all the bits. But it will be good if, from the Brte side, you took a very close look whether we have enough of that in the Yang model. Thanks.
So I left the discussion with the feedback I gave on the Yang model for beer. I hadn't looked specifically into the Brte Yang model yet, because I think the thing I would first like to see is that we have a good representation of the BIFT in the common beer Yang model. I'm not sure if an update was done on that. So that's what I would like to get back and discuss next.
Yeah, I think the discussion was hung whether we should split the Yang model around along the Brte, or try to keep it together, both the beer and the Brte. Okay.
And I think that discussion to me would be coming after having discussed how to put BIFT information into the beer Yang model, which I think the last version I saw 3-4 weeks back wasn't in there.
Yeah, it was too weak to be writable. Yeah. Okay, thanks.
All right. So what's the intent of the video? Torres?
You mean the next point?
Oh, faster. I'm sorry.
with that,
I completely messed up. Right? I thought that was a TE video. I'm clarified now. Sorry. No, let's move on. Michael, that's right. That's why Michael sent me the link. Goodness, I got Torles in the mind. Thanks, Torles. As always, entertaining. So, Michael, is he there? Or he's not here, and we're going to run the video instead? Was that the intent? I missed that. Looks like he's not here.
No, I'm here. Can you hear me?
Oh, I hear you now. Oh, you popped
okay.
up. I was scrolling down, and you popped to the top. Great.
Yeah, we prepared a video to have all the things together, and I think the video is nicer than a live presentation from our side.
So run the video instead of following slides.
Exactly.
Oh, okay. I'll run them from here. I believe it's loaded. It'll be a quick fractal freak show until I change screen, so bear with me. Okay, I just paused it just to make sure you guys can hear that. Can you hear that?
I couldn't hear that.
You could not hear the video. All right, that's a problem. So what's happening, the video plays out of my speaker, but it has to be picked up by the mic in order to be sent back out. Wow, because all it does is give me share screen, not share app. Yeah, it doesn't let me do that. I'll play a bit more, but I'll let it play while I switch back over. Can you hear any of that?
Nope.
All right. We got to find a Michael. Looks like we have to go through the slides then. You okay with that?
Stefan is here, and he can give the talk.
Excellent. Okay. Do you have the slides to share?
Yes. I tested because my microphone does not mute the video as far as I see, so maybe I could try to share it.
Go for it. Yeah, if you can try to do that, go for it. Okay. Screen granted.
Okay. So a short test, if you can hear it.
Hello, everybody. My name is Steffen Lindner. I'm part of the chair's committee.
I think you could hear it, right?
Works.
Works for me.
Okay, perfect. Then I can start the video.
Hello, everybody. My name is Steffen Lindner. I'm part of the chair's communication networks at the University of Tübingen. Today, I will present the latest update of draft Gen-BIER-2021. It is a merge of the previous version of the draft with draft Merlin BIER-2021 that presented tunnel-based BIER-2021. The presentation is completely revised and concepts are generalized. The updated version of the draft introduces an architecture for BIER-2021, which I will present today. Further, the draft introduces operation modes that consist of protection levels and backup strategies. In the proposed BIER-2021 architecture, BIER neighbors are connected in two different ways. Either through a direct connection, that means directly over the link layer, or via an indirect connection, for example, through a tunnel of the routing underlay. Further, we define three different forwarding actions for FAS3 The forwarding action plane corresponds to the default forwarding in BIER with direct connection. This means that a BIER packet is sent to a directly connected BIER neighbor. The forwarding action tunnel encapsulates the BIER packet with a tunnel header towards a not directly connected BIER neighbor. This corresponds to the default forwarding in BIER with indirect connections, for example, with the help of an IP tunnel. The forwarding action explicit forwards the packet over an explicit path to a BIER neighbor. This may be done through segment routing or other technologies. The explicit path must be given. A backup forwarding entry consists of a backup FBM, a backup BIER neighbor, a backup forwarding action, which is either plain, tunnel, or explicit, and a backup entry active flag that indicates if a backup entry is active. The backup FBM for a specific BIER indicates all BIERs that share the primary and backup BIER neighbor of the BIER, and all BIERs that have the backup BIER neighbor of the specific BIER as primary BIER neighbor. With this information, we can specify a format for the BIFT to support FAS3. We call this form the extended BIFT that compromises the information from the regular BIFT, that means BIER ID, FBM, and BIER neighbor, as well as the backup FBM, backup BIER neighbor, backup forwarding action, and the backup entry active flag, short BA flag. FAS3 gets activated if a failure is detected. This may be done using a BFD or similar techniques. Thereby, the BA flag is activated for the effective forwarding entries. If the primary BIER neighbor is reachable again, the BA flag is deactivated. This might happen if the failure is no longer present, or if the primary BIER neighbor has changed, for example, due to reconvergence. The forwarding for a BIER is adapted as follows. If the BEA flag is not activated for an entry, normal BIER forwarding takes place. If the BEA flag is set for an entry, the corresponding backup forwarding entry is applied. This means that instead of the regular FBM and BIER neighbor, the backup FBM is applied and the packet is sent to the backup BIER neighbor via the specified backup forwarding action. it is important that all active backup forwarding entries are applied before the normal beer forwarding takes place. In the following, I will show why it is important to first process the active backup forwarding entries. We consider the given network with 7 beer-capable nodes, where every node is a BFR and a BFER at the same time. A beer packet for BFER B2 and B6 arrives at B1. In the failure-free case, B1 first processes the bit for B2 and forwards the packet copy to B2. Afterwards, B1 processes the bit for B6 and sends a packet copy to B6. There's only a single copy of the packet per involved link. Next, we look at a failure case without prioritization of backup forwarding entries. Let's assume that the link between B1 and B6 fails, and that the backup forwarding entries for B6 are activated using the BA flag. First, B1 again processes the bit for B2 and sends a packet copy over the link B1, B2. Afterwards, the backup forwarding entry for B6 is used. In this case, B2 is a valid beer LFA for B6. Therefore, B1 sends again a packet copy to B2, which is forwarded to B7 and in the last step to B6. In this case, the same packet traverses the link B1, B2 twice. Once for BFER B2 and the second time for the BFER B6. At last, we'll look at the same failure case, but with prioritization of backup forwarding entries. B1 first processes the backup forwarding entry for B6. Therefore, B1 sends a copy of the packet to B2 and applies the corresponding backup FBN. The backup FBN for B6 also includes B2, and therefore no additional packet copy is sent to B2. We therefore don't get redundant packets when we first process the backup forwarding entries. That means backup forwarding entries should be processed before primary forwarding entries are processed to avoid redundant packet copies. The extended BIF can be cumbersome for 2 reasons. First, prioritization of backup forwarding entries must be done explicitly. Then, the normal beer forwarding process is affected. Therefore, we propose 2 variants for BIF organization that prioritize backup forwarding entries implicitly and are closer to the existing beer forwarding behavior. There may be platform-specific arguments for any BIF organization variant. One BIF organization variant comprises a primary BIF, which is the same as the regular BIF, and a single backup BIF that contains the backup information shown below. The forwarding with the primary BIF and a single backup BIF is adjusted as follows. First, all entries with BA activated are processed in the backup BIF. Afterwards, the primary BIF is processed. The advantage of this approach is little memory consumption, and its behavior is well defined for multiple failures. Another BIF organization variant are a primary BIF and multiple failure-specific backup BIFs. The failure-specific backup BIF contains the forwarding entries for both unaffected BFERs and for affected BFERs. Its advantage is that beer forwarding process is the same as on the regular BIF. Beer fast reroute can support different operation modes. An operation mode consists of a protection level and a beer fast reroute strategy. Protection levels are link protection and node protection. With link protection, it is not allowed that the backup path traverses the failed link. With node protection, it is not allowed that the backup path traverses the failed node. Link protection protects against link failures, while node protection protects against link and node failures. However, node protection is more difficult to achieve than link protection. In the presented draft, we propose two backup strategies for BFAS reroute: tunnel-based BFAS reroute and LFA-based BFAS reroute, both for link and node protection. Hence, there are multiple operation modes for BFAS reroute with their own advantages and drawbacks. Tunnel-based BFAS reroute leverages the fast reroute capabilities of the routing underlay. The assumption is that tunnels on the routing underlay are quickly repaired after failure, so that tunnel traffic is not affected. In the case of link protection, the affected BIER packet is tunneled to the BFR neighbor, for example, via an IP tunnel. In the case of node protection, the packet is tunneled to the next hop through the underlay. If the packet is destined for the failed next hop as well, another copy is tunneled to the next hop. Another option for BFAS reroute is LFA-based BFAS reroute. Here, the well-known principles of IP LFAs are applied to BIER, such as normal LFAs, remote LFAs, and topology-independent LFAs. However, we cannot simply take the LFA information from the routing underlay as a BIER LFA must be a BFR. Therefore, BIER LFAs are similar to IP LFAs, but they are not always the same. Like for IP LFAs, there are normal BIER LFAs, remote BIER LFAs, and topology-independent LFAs. Normal BIER LFAs use the backup forwarding action plane. Remote BIER LFAs use the backup forwarding action tunnel. And TI BIER LFAs use the backup forwarding action explicit. In the following, I want to show an example of tunnel-based BFAS reroute. On the left side, we see the previous network example with the default distribution tree at B1 for the BFERs B7, B5, and B4. On the right side, we see how tunnel-based BFAS reroute forwards the BIER packets when BFR B6 fails. Tunnel-based BFAS reroute tunnels the packets to the next hop when the primary next hop fails. Therefore, B1 tunnels the packets for BFER7 directly to BFR7, as BFR7 is the next hop. The same applies for BFER B5. The packet for BFER B4 is also tunneled to BFER 5, as BFER 5 is the next hop for B4. At BFR B5, the tunnel packet gets decapsulated and the packet copy is forwarded to B4. The backup path to B4 via B5 is longer than needed. In this example, we have one redundant packet on the link B1, B2. If we apply LFA-based BFAS reroute, we get a different distribution tree for the failure of BFR B6. B7 can be reached without a tunnel, as B2 is a valid BIER LFA. B4 is reached over a tunnel via B3. B3 is a remote BIER LFA for B4 in this example. B5 can't be reached with a normal BIER LFA or a remote BIER LFA. The only possibility to reach B5 is to send a packet via an explicit path to B4. B4 then can forward the packet via its default forwarding behavior to B5. This example also illustrates why IP LFAs and BIER LFAs are not the same. If B3 is not BIER capable, it cannot act as remote BIER LFA for B4. Then, B4 can only be reached via an explicit path. One of the main advantages of tunnel-based BFAS reroute is that it simply reuses the fast reroute mechanisms of the routing underlay. This leads to a simple computation of backup forwarding entries that can be directly derived from the primary BIF of a PLR and its BFR neighbors. Further, the forwarding action explicit is not needed. The main disadvantage of tunnel-based BFAS reroute is that it requires a routing underlay that has fast reroute capabilities. If the routing underlay only supports link protection, there is no way to support node protection. Further, tunnel-based BFR3 route introduces header overhead, as both link and node protection need a tunnel header. Another drawback is that tunnel-based BFR3 route with node protection might lead to redundant packets even when backup forwarding entries are prioritized. One of the main advantages of LFA-based BFR3 route is that it does not rely on the fast reroute capabilities of the underlay. Moreover, it can provide better protection quality on the BIER layer than on the IP layer when the IP layer does not support fast reroute or fast reroute with only link protection. Another advantage is that LFA-based BFR3 route avoids header overhead for normal BLFAs. A major disadvantage of LFA-based BFR3 route compared to tunnel-based BFR3 route is that the computation is more complex. Further, computation of BLFAs requires routing information from the underlay to ensure that the packet does not traverse broken links or nodes. In contrast to normal BLFAs, both remote and TI BLFAs require additional header overhead. If only some IP nodes are BFRs, BLFAs will require more remote and TI LFAs than IP LFAs, and the support for explicit tunnels may not be trivial. For the next steps, we welcome comments and request the adoption of the draft as a working group document. Hello.
Okay, that was it.
That worked. Any questions? I don't see any hands going. Well, thanks for that, Michael. That was helpful.
Okay, so the adoption thing will go to the list, right?
Yeah, we can do a hand now, and then that gets recorded
Sure.
actually for list. So let's see. Let's
Okay.
join the queue.
Can you run it, Greg? Mm-hmm.
I think I'm going to find it here. Where is it? Show of hands tool. This is the bear with me, I have to give it a name. All right. Who thinks this is ready for adoption? This is just a rough, there we go. All right. They're still coming in. We're up to 8 and no dissent. All right, shows a good trend. We'll take it to the list. Thank you much. Ending the call, and that goes to our log. Excellent. Next up, PCE-based BIER. Excellent. None's here. Do you have the deck you can present? There it is. Requesting screen already. Bam. And your screen is granted.
Can you hear me?
Yeah, you're good.
Okay. Good afternoon, BIER experts. I am Huanan Li from China Telecom. I am going to introduce our draft. Its name is PCE-based BIER procedure and protocol extensions. This presentation contains two parts. First, I will introduce why we propose PCE-based BIER and its solution. In the second part, I will introduce extension for PSAP. Compared with traditional multicast technology, BIER doesn't need to establish a multicast forwarding tree for each multicast traffic and save the multicast flow states, which will reduce the resource occupation and facilitate large-scale development of multicast service. In SDN scenario, users don't need to join the multicast tree hop by hop, improving the management efficiency. We specify PSAP extensions to optimize the implementation of multicast source registration or revocation, receiver automatic discovery and forwarding control of multicast data by using PSAP messages to transmit multicast management signaling in SDN scenario, combining with the forwarding characteristic of BIER. By using this mechanism, the unified management of BIER multicast can be implemented and the impact of BGP update on controller can be reduced. An example of PCE BIER topology for a BIER domain with a controller as PCE is shown in this page. Ingress and multicast source information to the controller via PC report message for multicast source registration. Then the controller feeds back the registration result to Ingress. If the controller accepts the registration, it will save the multicast source information to database and wait for the egress information. When egresses receive IGMP or MLD messages, they will convert IGMP or MLD messages into PC report messages and send them to the controller. Controller stitch bit strings of ingress and egress together and send a new bit string to ingress where PC updates message informing the ingress how to forward or stop forwarding. Ingress encapsulates BIER header based on bitstring and forwards multicast data based on BIFT tables and VPN information. The number of receivers is regularly synchronized between egress and controller, or between controller and ingress. We newly defined a capability flag and 4 objects to extend the open, report, and update message for PSAP. The multicast source registration object, called MSR object, is used for the registration and deregistration of multicast source, as well as corresponding response in report, PC report message and PC update message, respectively. Flag R bits indicates whether the action of the message is a registration request. Flag A bits indicates whether the request is successful. Auxiliary data is used to carry authentication information. Multicast receiver information object, called MRI object, is used for joining or leaving a specific SG in report message. Flag S bit indicates whether to join the requested SG. Forwarding label is used for distinguish receivers at the forwarding layer. Forwarding indication object called FI object is used for informing ingress to forward packets of a specific SG to receivers in PC report message. Flag F bit indicates whether to start forwarding multicast data. Multicast receiver states object calls MRS object is used for synchronizing receiver information in PC report message and PC update message. In report message, the number of receivers refers to those connected to an egress in a specific SG. In update message, the number of receivers refers to all receivers in a specific SG. In open message, BIER multicast capability flag instead for PCE capability TLV in the open object need to be set to support BIER multicast. Report message is extended to optionally include MSR object, MRI object, and MRS object after the path objects. Update message is extended to optionally include MSR objects, FI object, and MRS object after the path object. That's the main content of this draft. Any comment on our work are welcomed. Thank you.
Okay, I seem to be the only one on the mic. So thanks a lot. Interesting presentation, surely valid. So two observations from my side. That's just one way to use a controller architecture with BIER, right? Which I would consider a low touch, because you just touch basically the ingress of the network. It's absolutely conceivable, like with Brte, that somebody goes and programs all the bits into all the nodes and has, a very high touch controller architecture. Or they will do something similar to you, but with, the BIER FRR specifically, as it's just suggested here. So I would be reluctant to call this thing BIER multicast capability bit on PC. Call it something else, give it a more distinct name. So this is, this light touch controller architecture that you're introducing here. Or otherwise talk about generalization, what it means BIER in PCE when you use the different deployment models. The other observation is that your packet formats are very tight. I would make them a little bit more flexible using TLVs, because you may be adding more things into the signaling later in the next versions. Whereas right now it's all pretty hard coded and very tight, like this auxiliary data being authentication. So you can't add, I don't know, backup, whatever, you may have backup domain with the backup subdomain or something, like we do it for LSPs, primary, secondary, and so on. So again, one observation, don't call it BIER, capability, because there will be other deployment models. So call it, I don't know, BIER light touch PC capability or something, or make it more generic. And second thing, whether you don't want to break up the packet formats into a little bit more flexible TLV formats, so when you add new things, you'll have a easier time to do that. Sandy? Oh, it's Jeffrey. Everybody's Zhang, sorry.
Okay, so we call it BIER flow overlay, PCE-based BIER flow overlay.
something. I'm okay. I have no opinion. I just, I'm just pointing out it's just one deployment model.
Looks like we wrapped up. No more questions?
Yes, can you hear me?
Excellent. Very good. Thank you for that. Now we're, all right. Imo, you're
So-
here. Can you have the decks that you can present?
Yeah, maybe I can try.
Excellent. Okay. I'll grant. You are granted. Take it away.
Okay. So can you see my screen? This one?
Meeting says it's being
Can you
started.
see this one?
Still don't see it.
Don't see it?
So I
Oh,
granted, your status shows that you are sharing, but all we see is the box text saying the screen sharing is being started. Is there something on your end you've got to confirm? Anyone from MeetEcho here?
Yeah, I don't see the stuff either.
Oh, there we go. Okay, your share's coming up. Excellent.
Okay, good. Can you see the slides?
Well, not
Not
yet. We
yet.
see the fractal display of your screen going into infinity. So select your slide deck, and it'll take over.
Slide deck.
No. So you're right now. The web displays what you have up. You need to display your screen of your presentation. Is that a different application?
I just opened the PowerPoint.
Yes.
So can you see the PowerPoint slides?
Open them up, and we should see them pop up.
Yeah, I already opened the PowerPoint slides.
Well, then select PowerPoint, because right now the focus is on your web browser.
So just full screen. Can you see the slides?
No, we're still looking at your web browser, at the MeetEcho screen.
Oh, that's interesting. Okay.
Do you have two screens?
No, just one screen.
Okay, and what are you looking at? Do you see the
Stop.
looks like your sharing just ended. So go ask again. All right.
Yeah, just try again to see what happens.
Granted, here it comes.
Can you see right now?
Boom, we got them. Very good.
Oh,
Thank you.
good. Finally, we get it. Thank you very much. Very patient. So today, hello everyone. Today I'm going to talk about the Ospf extensions for BRTE. So right now, for every BFR of egress node, those ID has already been distributed through Ospf. So in BET system, those IDs for egress node is called local decap adjacency. In BRTE, for every link, there's a bit positions is configured on each end of the link. So this bit position is called forward connected adjacency in BRT system. So for example, in this topology, we have egress node D has a ID 1, we have egress node F, have ID 2, and so on. So for each egress node D, F, E, H, and A, we have IDs. Those IDs already distributed in the network through IGP. For each link in BRTE, we have bit positions on each side, each end of the link. For example, for link between H and D, we need to configure 2 bit positions. Each bit position is configured on each end of the link. For example, on on node H end, we configure bit position 28 prime. On node D end, we configure bit position 27 prime. So for each of these bit positions, so we propose to distribute these bit positions for each link through Ospf. So more specifically through Ospf version 2 right now. So after distribute these bit positions, so we can have take advantage of this information, because all the information about the ID for egress node and the bit positions for each of the link already distributed in the network. So in the every ingress node of the network, that ingress node can compute a Brte path crossing network. In addition to that, every BFR node in the network, they can compute local backup paths for providing protections for its neighboring nodes. For example, in this topology, in order to provide protections against the failure of node C, node B can compute backup paths for node C. So node B will compute backup paths to C's next hop, for example, F. So node B will compute the local backup paths from B to F. So B to F, the backup path is from B to E and then to F. So it's in the red color. So node B can also compute backup paths from B to D, which is next hop of C. So the backup path from B to C is from B to G to H and to D, so which is in green color. So B can also compute backup paths from B to I. I is also next hop of C. So with all these backup paths, node B can provide protections for any Brte path go through B to C when C fails. So for Ospf version 2, we already have extended link OPAC LCs. So this OPAC LCs can contain multiple TLVs. So this TLV can include extended link TLVs. In this extended link TLVs, we define a new sub-TLV, which is called Brte sub-TLV. So this Brte sub-TLV will contain the information about the bit positions of a link. So this Brte sub-TLV is, in fact, is an extension to the Ospf v2. So this sub-TLV mainly contains the bit position on one end of the link attached to the total node. In addition to these bit positions, it also contains subdomain ID and the multi-topology ID and the Beer algorithm and IP algorithm and so on. So that's about the Ospf version 2 extensions for BATEs. So any questions and comments regarding to this draft?
The name affiliation, please.
C. Lindum, Cisco Systems. Hey, Wimo, I was just going to say that in OSPF for both this extension and one for OSPF v3, we don't have, I know you don't define any, but we don't use the moniker sub TLVs. Because in OSPF, because we can nest TLVs to anything, to any level. So we wouldn't want to keep adding sub on the prepend sub for each level of nesting. So everything that's not yeah. So everything that's not a top level TLV is a sub TLV. You don't need sub or sub or anything like ISIS does.
Okay, thank you very much for your comments. Okay, good. So next one, I'm going to talk about the Ospf version 3 extensions for Brte. So this is similar to Ospf version 2. So in Ospf version 3, we already have extended router states. This router states may contain TLVs. So that TLV may be a router link TLV, and the router link TLV can contain TLVs, Brte TLVs. So Brte TLV will contain the bit position attached to a node, which advertise the router state. So the Brte TLV has the same structure and the contents as we already presented for Ospf version 2. So it will mainly contains bit position on one side of the link, and subdomain ID, multi-topology ID, and so on. So this is the first, almost same as Ospf version 2, just use different LSAs and the TLVs. So any comments regarding to this draft? So I'm going to next one, the ISS extensions for Brte. So in ISS, we already have TLVs of type 22 and 222. So for TLV of type 22, it may contain sub-TLVs. So in this sub-TLV, we can have Brte sub-TLVs. So this sub-TLV will contain the information about bit positions configured on one side of the link. In addition to that, the TLV of type 222, which is for multi-topology, so in the environment of multi-topology, so that multi-topology TLV can contain the structure of TLV of type 22. So in that case, the structure of TLV of type 22 can contain Brte sub-TLVs. So eventually, extension is Brte sub-TLVs. So the Brte sub-TLV here has same format and content as we talked about before, except that in ISS, the type is 1 byte and the length is 1 byte. In Ospf, the type is 2 bytes and the length is 2 bytes. In addition, other than that, everything is the same. So any questions regarding comments for this draft?
Yeah, minor, Tony P. Juniper. If you can flip to the previous slide, please, one.
Which one?
The next one. 13, yeah. So only observation is for the bit position and the end bit position, I would put one reserve to align those on 16-bit boundaries. It's extremely painful to parse stuff and put together numbers if they're not on the word boundaries.
Yeah, good suggestion. Yeah, that's very good suggestion. Yes. Yeah, we'll change that one in the next version.
We there?
Yes, I'm here.
Okay.
Yeah, I'm done. I'm done for my presentation. Thank you.
Got it. Any questions on this? Oh, I see your last slide there. Oh, got it. Okay. It didn't go down to a. Go down one more slide. Boom. There we go. All right. Any questions on this or the previous? Anyone? Pretty solid. So the intent, I imagine, for all three of these would be for adoption and move this up forward, and that's why we're here in the first place. Brand new. Honestly, I did slip this time. I have not read all three of these, so I'll refrain from comment. But let's just do. I guess let's do a hands for each one of them, just so we have a queue, and then we'll take them to the list. We see intent from here. All right. I will begin. I remember how to do this. Gallery clock. No. Meeting materials. Show of hands tool. There we go. All right. I'll just give a adoption name. Bear with me. Session started. So if things should be adopted, raise your hand. You can actually do a do not raise hand if you choose. There we go. All right, still coming in. Seven say it's ready. One say it's not. Still pretty solid. We'll take that to the list and get some action. All right, I'll end that session. Here comes the next. Rurik, did you have a question? Or are you just trying to raise your hand for the call? All right, Brte Ospf v3 adoption call. Settling on 6. All right, looks good. We'll take the up to 7 now. No dissent. Once, twice. Ending session. We'll take that to the list. And one more. The TEISIS draft. All right. Looks like people figured out the tool quickly this time. Nice. All right. Even more support. We're up to 9. No dissent. Yeah, that was quick. Very good. All right, I'll end that session. This will also go to the list. I want to thank all of the presenters for being prepared with backup and slides ready to roll. That was great. I know we get lulled into complacency when we have tools that work well, and I have to say, MeetEcho has worked really well in the past. A little snafu probably just because of our move. But that integration was great, and nice to have the slides prepped when things fall apart. Tony had a question. No V3 extensions. Did you want to take that to the mic, Tony? Or is your mic?
Yeah, where are the IETF version 3 extensions? Of course, only the IGP people will get the joke.
Fantastic. Okay, anyone not signed the blue sheet? I just had to ask that. You know we don't have blue sheets. This is great. We're actually early, which is wonderful. Do you have any press and info, stuff want to run off to other groups? Where we're headed? We're ready to roll? Anyone? No hands? AD, anything to yell at us about? Give us a direction for? Nudge us in a direction? Nothing. That was smooth. Thank you, everybody. Again, thanks for your cooperation and patience through the tech snafus and our ability to adapt and respond and present regardless. When the question came up. Nope. All right. Thanks, Alvaro. Thank you, everybody. Thank MeetEcho for making this work for us. Have a great week, everybody. Cheers.
Cheers.
Yeah. Yep.
Cheers, beer.
Hey, if anyone's still on and you're going to share something going down the road, I found the upper right corner, the wrench button. You click on that, it gives you up into manage slides, and that seems to have the link to the data tracker, whereas the presentation folder didn't. So it's still there, just the link's broken. If you can find it up in the right-hand corner, you might have some better luck than I had. Close that.